Hello and greetings to everyone. We have the following questions to answer. The questions are based on probability. Question 1 says a fair die is thrown. A die is simply a cube with numbers on each of its faces. The numbers are from 1 to 6. The question continues. Find the probability of getting, for A we have an even number, B an odd number, C a prime number, D a number greater than or equal to 3, and lastly C a number less than 1. Let's answer the question. Take down solution. For those of you who play Ludo, you know a die very well. And the plural for die is dice. Question 1. We have been told a die is thrown. Find the probability of getting an even number. First thing we need to start by doing is we need to write out the sample space. That is, it is the set of all possible outcomes when this die is thrown. It is noted by using this Greek letter. Sample space, our sample space, this is set. Is simply, it has first element 1, 2, 3, 4, 5, and lastly 6. This is our sample space. Next, we have to find the probability of getting an even number. First, when we talk of probability, we know probability is the likelihood of something occurring. And for us to get the probability, we simply take the number of favorable outcomes, probability, simply equal to number of favorable outcomes over total number of possible outcomes. Total number of possible outcomes. And we know for any event A, the probability of the event A lies between 0 and 1 inclusive. That means probability can never be negative and probability can never be greater than 1. Go back to our question. For question A, probability of getting an even number, we are going to denote it as such: P an even number. This P stands for probability. We read this as the probability of getting an even number. So this will simply be equal to, we'll simply go to our sample space, this set. We count the number of even numbers which are found here. When we talk of even numbers, we are simply referring to those numbers that can be divided by 2 without any remainder. The even numbers we have here, we have the number, we have 2, we have 4, we have 6, we have 1, 2, 3. There are 3 even numbers. We are going to write down 3 here. All over the total number of possible outcomes. These are the total number of possible outcomes here. We have 1, 2, 3, 4, 5, 6. There are 6 of them. This can be further simplified. If we simplify this will give us 3 will go here 1, and 3 will go into 6 2 times. Our answer will simply just be a half. So the probability of getting an even number is a half. For B, we need the probability of getting an odd number. The probability of getting an odd number, No, we are going to make use of this our formula again. Number of favorable outcomes. That means we are going to count the number of odd numbers in the sample space. We have 1, 2, 3. There are 3 of them. We're going to write 3. We divide by the total number of possible outcomes. There are 6 of them. So this can be simplified. This will give us 1/2, which a half. Next question, C is asking us to calculate the probability of getting a prime number. When we talk of a prime number, we are simply referring to a number that has only 2 positive factors, that is 1 and the number itself. If looking at our sample space here, the prime numbers we have here, we have the number 2. The number 2 has only 2 positive factors, 1 and the number 2 itself. The number 3 is a prime number. It has only 2 positive factors, 1 and 3 itself. The number 5 is a prime number. It has only 2 positive factors, the number 1 and 5 itself. Counting the number of prime numbers we have here, we have 1, 2, 3. There are 3 of them. This will give us 3 all over. The total number of possible outcomes, we have 6 elements in the sample space. We are going to write down 6 here. If we simplify, this will give us 1 all over 2.5. Next, we go now to D. D says we should find the probability of getting a number greater than or equal to 3. Probability of getting a number which is greater than or equal to 3. We know this symbol stands for greater than or equal to. In this case, we need the number of favorable outcomes. And in this case, the favorable outcomes, they are those numbers greater than or equal to 3. That means the numbers from 3 right up to 6. So we are going to count them. We have 1, 2, 3, 4. There are 4 of them. 4 all over the total number of possible outcomes. There are 6 of them. We can simplify this fraction. 2 will go into 4 2 times. 2 will go into 6 3 times. So this will give us 2/3. Next, we have to go to question E. Question E says a number less than 1. For question E, a number less than 1. Probability of getting a number less than 1. We know we denote less than by making use of this symbol. It will simply be equal to, we are going to look at our sample space to see if we have any outcome which is a number less than 1. Looking at this as sample space, we have no outcome which is less than 1. That means 0, -1, -2. We have none of such outcomes in this our sample space. So in this case, the number of favorable outcomes are 0. We are going to write 0. Then we divide by the total number of possible outcomes. There are 6 of them. 0 divided by 6 gives us 0. So that means the probability of getting a number less than 1 is 0. It is not possible to have a number less than 1 when you throw a die. Question 2. Let's look at question 2. Question 2 says a coin is tossed thrice. Find the probability of getting, question A, 2 heads, question B, at least 1 tail, question C, all heads or tails, Question D, 2 heads and a tail, or 2 tails and a head, in that order. Let's answer the question. Question 2. First thing, we need to start by writing out the sample space. It is very important. We denote the sample space by using the Greek letter omega, or we make use of the letter capital S. It is simply equal to, first, we need to write out the number of possible outcomes when a coin is tossed thrice. Remember, when a coin is tossed, we can either have a head, or use H for a head, or we can have a tail. I'll use capital T for a tail. So these are the two possible outcomes when a coin is tossed. Now, when it is tossed thrice, you can either have a head, head, head. You can have 3 heads. It is possible. You can have head, head, tail. You can have 2 heads and a tail. We can have head, tail, head. It is possible. We can have tail, head, head. It is possible. We can have tail, tail, head. We can have tail, head, tail. We can have head, tail, tail. And lastly, we can have 3 tails. So this is our sample space. Now we can proceed to find the probability of getting, question A says the probability of getting 2 heads, P of 2 heads is simply equal to, we are going to count all the outcomes where we have 2 heads. We have here we have 2 heads. So I will count this one. We have 1, we have 2, we have 3. There are 3 of them. We have 3 outcomes where we have 2 heads. We are going to divide by the total number of possible outcomes. We have 1, 2, 3, 4, 5, 6, 7, 8. 3 over 8. So this is our probability of having 2 heads. Next, for B, we are required to find the probability of getting at least 1 tail. Probability of getting at least 1 tail. When we talk of at least getting 1 tail, that means the minimum should be 1 tail. That means you can either have 1 tail, or 2 tails, or 3 tails. So in this case, we are going to count all the outcomes where we have a tail, or 2 tails, or 3 tails. We are going to count them. So this will be the first. We have 1, 2, 3, 4, 5, 6, 7. There are 7 of them. So we have 7 possible outcomes. 7 possible outcomes where we have at least a tail. There are 7 of them. We are going to divide by the total number of possible outcomes. There are 8 of them. You can see here we don't have a tail. We have just 3 heads. Divide by 8. The probability will simply be 7 over 8. Next, we go now to question C. C says all heads or tails. That means we have all the 3 as heads, or all the 3 as tails. P of all heads or tails. We know this is simply equal to P of, this will simply be equal to the probability of all heads plus the probability of all tails. This will simply be equal to, if we count here where we have all the 3 as heads, this is the only outcome, just 1. So the probability will simply just be 1 over 8 plus This other one, we have all tails, all the three are tails. We have just one outcome, 1 over 8. We have to add these two fractions. They have the same denominator, so we are just going to maintain the denominator, which is 8. Then we add the numerators. 1 plus 1 gives us 2. This can be further simplified. This will give us 2 will go into 2 1 times, 2 will go into 8 4 times, 1 quarter. Or we can still get this probability directly. In this case, P of all heads or tails can simply be obtained by, you just go to the sample space, you count all the outcomes where you have either 3 heads or 3 tails. We have just 1 2. We take 2 all over the total number of possible outcomes. There are 8 of them. If you simplify this, will give you 1 quarter, the same result. Next, question D says 2 heads and a tail. Question D is to find the probability of getting 2 heads and a tail, or two tails and a head in that order. That means first you have 2 heads, head, tail, or you have a tail, head, in this order. You should not take an outcome where you have head, tail, head. These two, they are not in the same order. So in this case, we need the probability of having 2 heads. I'll write it down as such: head, tail, or or most of we do not, or by making use of union, tail, head. This will simply be equal to the probability of getting 2 heads and a tail plus the probability of getting 2 tails and a head. This will simply be equal to, if we go to our sample space, we have just one outcome where we have head, tail in that order. So the probability of getting head, tail in this order will simply be equal to 1 all over 8. 1 over 8 plus the probability of getting tail, head in that order. We have 1 all over 8. Next, we have to simplify. This will simply be equal to 1 8 plus 1 8 will simply give us 2 over 8. Simplify this will give us 1 quarter. So we are done with the solution of that problem. Next, now we go to question 3. Question 3 says a bag contains 7 similar balls, of which 3 are white and 4 are black. A ball is chosen at random from the bag, its color noted, and the ball is kept in an empty bag. That means there's a different bag which is empty. A second ball is taken out from the bag, that means from the same bag, with its color noted. Find the probability that the 2 balls are both white, B, both black, C, one of each color, D, white and black in that order. For us to answer this question, we are going to make good use of the probability tree diagram. We make use of the probability tree diagram when the probability contains a mixture of independent and mutually exclusive events. When we talk of independent events, that means the occurrence of one event does not affect the occurrence of the other event. And when we talk of mutually exclusive events, that means they are events that cannot occur at the same time. For us to answer this, first thing, we are going to start by letting let's let W to represent a white ball. white ball, and capital B to represent a black ball. Now we need to draw our tree diagram first. Tree diagram, it has branches as such, of which the branches, they give us the probability. So this is that our back. If you are to remove a ball from that back, you either have a white ball or you will have a black ball. And the probability of you getting a white ball, we know that the number of white balls denoted as NW, the number of white balls. We have been told there are 3. Number of black balls, 4. And we know the total number of balls, N of omega, the sample space, there are 7 of them. Now, the probability of getting a white ball will simply be from the first removal. When you remove a ball, the probability of getting a white ball, we are simply going to divide the number of white balls by the total number of balls. So this will give us 3 over 7 is the probability here. Next, the probability of getting a black ball, we are simply going to divide the number of black balls by the total number of balls. This will give us 4 over 7. Write it here. Next, for you to know if your tree diagram is correct, when you sum the probabilities on a branch, it will always be equal to 1. If you add 3 over 7 plus 4 over 7, 3 over 7 plus 4 over 7, this will give us 7 over 7, which is equal to 1. It's always equal to 1. So you take note of that. Next, for the second removal, you can either have a white ball or a black ball. You can either have a white ball or a black ball. As such. Now, when the first ball is removed, the ball is kept aside in an empty bag. So that means the total number of balls in that bag now will reduce for the second removal. The number of balls will reduce to 6 since 1 ball has been kept in an empty bag. Now, if that ball which is kept in an empty bag is a white ball, here we have white since the first ball is white. If that ball is a white ball, the number of white balls will reduce now to 2. There will be 2 white balls. And the total number of balls in that bag will be 6. So the probability now of getting a white ball will simply be 2 over 6. Now, the number of black balls in that bag will remain the same, unchanged, since the first ball was white and that white ball was kept in an empty bag. So the number of black balls will remain 4. The probability of getting a black ball will simply be 4 over 6. We can verify if we add the probabilities in this branch, 2 over 6 plus 4 over 6, it is simply equal to 6 over 6, which is 1. Next, for this other branch, if the first ball is a black ball and that black ball was kept in an empty bag, the number of black balls will reduce. There will be 3 of them. And the number of white balls will remain the same, 3. Then the total number of balls will simply be 3 plus 3 is 6 of them. So in this case, the probability of getting a white ball will simply be 3 over 6, since the white balls will remain unchanged. The probability of getting a black ball will simply be 3 over 6, since 1 black ball has been kept in an empty bag. The number of black balls now will reduce to 3. Now, we are done with our tree diagram. This first one is for the first removal, for the first ball which is removed. For the first ball, and these other branches, therefore the second ball. Now we can proceed now to answer these our questions by making use of our tree diagram. we are asked to find the probability that the two balls are both white. That means you have white. In this case, for us to get that probability, we are simply going to take the branch where we have the first ball white, the second ball white. Looking at all the branches, you see here we have white. Here we have white, black. This one cannot be taken. Here we have black, white. Cannot be taken. Black, black. It cannot be taken. So we are going to make use of this branch. Question E, we have probability of getting white. This will simply be equal to, we know this is the same as the probability of getting white ball and a white ball, and we make use of intersection. We know the two events are independent. In this case, getting the probability will simply be probability of the first white ball times the probability of the second white ball. This will simply be equal to the probability of the first white ball is simply 3/7 times the probability of the second white ball, which is 2/6. This will give us we simplify, this will give us 3/7 times 2/6 can be simplified. This will give us 1/3. We further simplify this 3, we cancel this 3. We multiply, this will give us 1/7. The probability of getting a white ball and a white ball is simply 1/7. Next, the next question says we should find the probability of getting both black balls. That means P of black and black. This will simply be equal to, since they are independent, because the probability of getting the first black ball does not affect the probability of getting the second black ball. This will give us probability of the first black ball times the probability of the second black ball. So we are going back to our tree diagram. We are going to select the branch where we have the first ball as black and the second ball as black. You see, it is this branch, black. We are going to take 4/7 times 3/6. This will give us 4/7 times 3/6, which is simply equal to 4/7 times. This will give us a half when we simplify. This will simply be equal to, we know 2 go here 1, 2 go here 2 times. 2 times 1 remains 2 over 7 times 1 remains 7. Probability is simply 2/7. Now for question C says we should find the probability of getting one of each color. Talk of one of each color, that means having a white ball. The first ball is white, the second ball is black, or the second ball is black, the first ball is black and the second ball is white. This will give us a probability of one of each color simply equal to the probability of having white and black plus the probability of getting black and white. This will simply be equal to, first, we know for the first one, we are going to look at our tree diagram where we have white and black. We are going to take this branch where we have black and white. We are going to take this branch. The probability of getting white and black, we are simply going to take 3/7 times 4/6. This will give us 3/7 times 4/6 plus black and white 4/7 times 3/6. 4/7 times 3/6. This will give us, we can simplify this. This will give us 3/7 times, this will give us 2/3 plus, this will give us 4/7 times half. This will give us a 3. We can simplify 3. We cancel this 3 here. We'll be left with 1 times 2, which is 2 over 7, plus, here we can simplify this other one. 2 go here 1, 2 go here 2 times. 2 times 1 remains 2 all over 7 times 1, 7. So we are going to add these two fractions, 2 over 7 plus 2 over 7, which will simply be equal to, we are going to maintain the denominator because they have the same denominator. Then we add the numerator, 2 plus 2, which gives us 4. The probability will simply be 4 all over 7. We underline our answer. Next, we have to answer question D. And question D is asking us to find the probability that the two balls are white and black in that order. White and black. Probability of white and black in that order. That means you must take the first, that means the first ball must be white and the second ball must be black. If you take the case where the first ball is black and the second ball is white, you are wrong. So for us to answer this, we need our tree diagram. The first ball white, the second ball black, white, black. So we have to make use of this branch. Take note of this. So we are going to multiply 3 over 7 by 4 over 6. This will be equal to P of the probability of having a white ball times the probability of having a black ball, which will simply be equal to 3 over 7 times 4 over 6. This will simply give us 3 over 7 times, we can simplify this, this will give us 2 over 3. 3 will go here. 1 times 2 remains 2 over 7 times 1, 7. So this will give us a probability of 2 on 7. And we are done with the correction of the questions.